Hi, good morning, good afternoon, good evening, good night, wherever you're going to be viewing this from, what time it is there. Uh, we are students from the State Polytechnic of Malang, mechanical engineering students, under the study program Mechanical Production and Maintenance Engineering. Uh, this is part of our presentation for under the course of Advanced Machining Techniques that is being delivered to us by our lecturer, Pak Muzaki. And the topic we are going to be presenting about today is mechanical machining. And before we get into the presentation, we are the members. My name is Ajang, Deng, Arok.
My name is Mohamed Yusuf.
And I think we shall get right into the presentation. So let's start. Right. So before we start to dive into what chemical machining is, we have to first define it and get to know what we are going to be talking about. So chemical machining is a non-traditional material removal process that uses chemical reactions to selectively remove material from a workpiece. This process is primarily used for machining complex shapes, delicate features, or materials that are difficult to machine with traditional methods such as cutting or grinding. In chemical machining, the workpiece is exposed to a chemical solution, usually an acid or alkali, that dissolves the material in the areas that are protected by a mask or resist. The process is highly precise and is often used for materials such as metals, alloys, ceramics, and composites. It is commonly employed for creating intricate patterns, fine features, and for working with thin or fragile materials. Next, please. uh, on the working principles. Now, the first thing we do with the working principles, we have to do some pre-cleaning. Now, the workpiece is thoroughly cleaned to remove contamination such as dust, oil, and grease. This step is crucial for ensuring proper adhesion of the masking agents used in subsequent steps. So we know before we can do any kind of either being a chemical reaction or any kind of practical that we have to do, we have to make sure that the workpiece or whatever material or the tools that are going to be involved must be clean and separate from contaminations, because this is not going to give us the good results. So pre-cleaning here is the first step and one of the most important steps in the working principle. Now the second principle, working principle, is masking. Now a protective layer known as maskant of the is applied to areas of the workpiece that should not be affected by the etchant. The masking must be resistant to chemical reactions used during etching. So it's very clear the masking must be applied to the areas that we don't want to machine out, or areas that we don't want to have any kind of chemical reaction on. And at the same time, the masking must be non-reactive, because if it's reactive, it's going to react with the chemicals, and it's not going to do its work as a masking, because it's supposed to cover the parts that are not supposed to be machined. And if the chemicals touch it, it's going to react with them. And if the chemicals are more, if there are some more chemicals that are left after the reaction, it's still going to react with the area that we said was supposed to not be reacting with. So this is why it's important. We have to know what kind of the reacting properties. Is it a reactant material, or is it not reactant? We have to be careful with such thing. Now we have scribing. In some processes, the masking is selectively removed from specific areas of the workpiece using a scribing tool, exposing those areas for machining while keeping others protected. Now etching. The workpiece is immersed in a chemical reaction, which is the etchant, which reacts with the exposed areas of the material, the areas that we want to machine. This reaction dissolves the unmasked portions, effectively removing material according to the desired shape. We have the masking. After etching, the masking is removed either mechanically or chemically. This step ensures that only the desired areas have been machined, and any residue account on the removing material according to the desired shape. I'm sorry. These steps ensures that that only the desired areas have been machined, and any residual account on the workpiece is also cleaned off. So we are trying to make sure we have a clean uh, workpiece surface, the machined surface. Now the final cleaning and inspection. The machine part undergoes a final cleaning process to remove any remaining chemicals or residues. It may also be inspected for quality assurance to ensure it meets specified tolerance or surface finish requirements. So that was a little bit about the working principles and the steps that we need to put in place before and after a reaction. So this is the layout of how the reaction works. So we have the tank, we have the heating, we have cooling, we have the chemical reagent, we have the workpiece and the mass, and then the hanger. Now the hanger, I think, puts its use to have the workpiece in the solution, so that later on after a reaction we can easily remove. We can just I think you can see the hook there, like for hanging clothes. You can just pull it up, and the mask here has been laid because this area where the mask is, we don't need any kind of reaction or any kind of machining on this area. That's why we have the mask on there. We have the tank, which is the storage system of the workpiece, all chemical reagent, and the workpiece plus other parts of the reaction process or reaction mechanism of system. Next. Now the parts of a chemical machine. Now the important first thing is the workpiece, which is our center, which is the reason we are doing the reaction. So the first thing is the workpiece, and a workpiece is a material to be machined, which can be a metal, alloys, ceramics, plastics, or composites. The workpiece is often prepared and cleaned before being exposed to chemicals to ensure the process is effective. Now we have masking materials. Masking, or we can call it a resist. Masking materials are used to protect specific areas of the workpiece from being affected by the chemical etching process. Common masking materials are polymers, paints, or other coatings that are resistant to the chemical solution in machining. So it's very important. Let's not forget the reason why we do masking is to not have a chemical reaction on the areas of the workpiece that we don't want to be machined. So that's why we have this kind of the masking materials like the paint and polymers. And we have to be careful. It's not just any kind of type. It's the type that is not going to react. Let's not forget that reaction is one thing we don't want in the area of masking. So we have to be careful. So we'll go to the next part, which is the aching tank or the bath. Now the aching tank holds the chemical solution, which was the tank in the previous picture. The aching tank holds the chemical solution and the workpiece. The workpiece is either submerged in the solution or exposed to it in a controlled manner. Aching tanks can be designed for immersion or spraying aching depending on the process. Yeah. And we have the hanger, which I was calling the hook. Now the function of the hanger is used to suspend or hold the workpiece in the chemical bath or etching tank during the machining process. It is designed to keep the workpiece in a specific position, often fully submerged in the agent, while ensuring it is secure and stable. Now the stirrer or agitator. Now the function of the stirrer is used to agitate the chemical solution in the aching tank, and to promote uniform circulation of the chemical solution around the workpiece, which helps ensure consistent aching or material removal throughout the process. The next thing we have the heating system. Now some chemical machining processes require heat to accelerate the chemical reaction. A heating system, which in other words we can use heaters or temperature control baths. Now the heating system ensures that the chemical solution at the optimal temperature for etching. So we regulate the temperature according to how we want it. Yeah, let's go again. Yes.
Okay, the next is type of chemical machining. There is a 9 type of chemical machining. The first is etching machines. Second is electrochemical machining. Third is chemical milling. Fourth is laser chemical milling. Fifth is photochemical machining. Sixth is spray etching machines. Seven, chemical grinding machines. Eight, ultrasonic chemical machining. And the last is plasma chemical machining. And then this is the advantage and disadvantage of chemical machining. The advantage first is no mechanical stress. Second is ability to machine complex shapes. Next is minimal tool wear, and then suitable for hard or brittle materials. And then high precision and accuracy, no heat affected zone, low surface damage, works on thin or fragile materials. The last is environmentally friendly. The next is disadvantage. The first is limited to certain materials. Second is limited depth of material removal. Third is requires special equipment and expertise. Fourth is chemical handling and safety risk. Fifth is surface finish limitation. The next is expensive setup cost. And then environmental and disposal concerns. Eight is limited flexibility for large scale production. And then the last is relatively slow process.
Right.
And then thank you.
Yes, and that brings us to the end of our presentation. And we would love to beg for your pardon, and we apologize if there are any mistakes we made in the process of presenting our work. And if there's very little information that we gave out, we are also apologize for that. But I think as a person who never knew chemical machining or did not know much about it, I think you've known much a little bit, not everything about it, but you've got the idea of what it is. So we apologize for any mistakes made in the process, and if there's any little information, we also apologize. And I think this brings us to the end of our presentation. And thank you.
Done.
Yeah.